Hi and welcome to this ADF Academy video presented by Comsys. My name is Christian and today we're talking about commissioning of an ADF. To succeed with a commissioning, the most important thing is of course the installation of the active filter. And the bigger factor here is the airflow. We need to make sure that nothing is limiting the airflow of the active filter and nothing is preventing the air to flow in the correct way. Beside the airflow, we also have the main connections. Here we need to make sure that we have the three phases in correctly, protective earth connected, as well as the three CTs connected at the right position. Three phases, it is important to have them in the right order, so phase 1, phase 2, phase 3, but the active filter will tell you as well if this is not the correct way. And on the CT side, we just need to make sure that the CTs are in the correct position and that the cable are routed to the active filter in the correct way. Beside these external connections, we also have an internal auxiliary transformer. This auxiliary transformer is always connected to a parking terminal at delivery. So you need to make sure that the transformer is connected to the correct voltage level. So we have an internal 230 volt that is used for auxiliary parts. Now let's come over to the network connection. Once you connect your computer to the active filter, the systems will start to talk with each other. We can see here in the network settings that we have an unidentified network. This unidentified network simply means that there was no DHCP server that could be found. If we just look here in the settings, we can see that the settings are selected for automatic IP configuration. But because there's no DHCP server, we of course didn't get that information. So if we look here into the status, we see in details that there was an auto configuration, but this auto configuration has been done by this computer. So this computer automatically brought this computer into the IP range 169.254.XX. The benefit now is that we have the active filter in exactly the same IP range. This means I can now open any type of browser. The typical browsers that are supported is Chrome, Edge and Firefox, but every other browser works as well. And here I can now just go to the IP address of the active filter 169.254.254.254 and I'm able to log in to the active filter. We have a login interface, but the standard username is admin without any password. With that written in, I'm able to connect to the active filter and I see the basic information in the setup dialog. The interface is configured in a way that we have these cards here. In this case, we have two different cards, the setup and the about. We can add some extra cards over this home menu, for example, the configuration. There will be more cards coming up as soon as we're out of the setup mode. We will have a lot of different measurements that we're going to see as well. Beside the menu over here, we also have the start and stop functionality down here with the status information. So we are now in a setup mode where we need to make sure that the system is correctly configured. What we have here is a 150 amp module. This is already selected and this is fixed by this model key. We have one module installed, 100% power rating on that module. We have a 400 volt grid, so this is all correct. Closed loop operation on a 200 amp CT. The CTs are correctly installed, so we don't need to invert them. This is correctly here. So we have two more license keys here. We can ignore them for the moment. One of them is Modbus TCP, the other one is sensorless control, but that's it for the moment. Here in the setup window, we have the possibility to update the software and to import settings as well as export settings. So if I just click here on export settings, a file will be downloaded, and this file contains now all of the settings of the active filter. If I have several active filters that I'm working on with all of the active filter in the same configuration, I can simply create one file and then import this file to the other systems. Now we know that the setup, everything is correct. That means we can run a diagnostic. So we can just click here on Save and Run Diagnostic, and the filter will restart and start with the diagnostic phase. Now when the diagnostic starts, we do see a little bit more measurements. We see now here a general measurement window. We see an AC voltage waveform, we see an output current waveform, a CT current waveform, and then as well a AC voltage spectrum, output current spectrum, and CT current spectrum. Right now the filter is slowly charging up, so we can see here the DC link voltage is slowly rising up to a certain level where we can then start the active filter. And during that time, when it then starts, it will do some internal tests, some external tests, and then based on this information it will start to operate, or it will bring us an error. So what happened now is that the diagnostic failed. And the diagnostic failed on this test. So the test is detecting the CT current. It did not detect enough CT current to be able to identify if the phases are correct in the correct order. So we have now different possibilities. One possibility is we can get some more load in the system, or another possibility is override these CT checks. What we're going to do now is we're going to start with a little bit more load, and with the extra load in the network we will then be able to successfully pass through the diagnostic. Now we can see we have about 160 amps of current in the network, and with this current in the network we will be able to succeed through the diagnostic phase. What we need is about 3.5% of the CT ratio. So that means in our case it's 200 amp CT, so we need something in the range of 7-8 amps on the CT current to be able to run the diagnostic. So I can restart the system here, and with that we will be able to run the diagnostic. So now after the filter is restarted, the filter is checking a few internal things, and if everything is fine, then it will start the filter and it will run in idle mode for a few seconds. So we see now the DC link voltage jumped up to 850 amps. We see some output current here, and we're just checking internally that the active filter has everything that it needs to be able to correctly operate. This mode runs for about 10 seconds, and after this is done, it will stop the filter, and now we see we passed through the diagnostic. Now just restart the system here and we're able to go into normal operation mode. If you had to bypass the CT tests, there are of course always some possibilities for you. For example, what we can do is we can just inject a little bit reactive power to see if the CT is measuring correct information. So right now we can see that we have an -1 kVAR capacitive in the network. I will just make sure that everything is deactivated here. Start the active filter, and we will see it goes a little bit more capacitive after the filter starts. Now we're at 3.8 kVAR capacitive. What I can do now is I can inject some reactive power and see that the filter is measuring the right amount back. So if I just now inject 10 kVAR capacitive, then we should change from around 3.9 to about 13 kVAR. I save the information, and we're changing to about 10, 12, 11 kVAR. So that fits more or less in the range that we expected, and this is exactly what we want to see. So we see that the filter is seeing the correct result. We can do the same also in the opposite direction, where we just say we're injecting now 10 kVAR inductive. So we should go into the inductive phase now. Correct. So now we're at 8.4 kVAR inductive instead of the capacitive. So this is exactly what we want to see to make sure that the CT is measuring the right values and that we know that the phases are in the right order and measuring the correct data. So with this checked, we can now go to a real commissioning. We have here a distorted grid. We can see that we have about 7% voltage distortion and about 30% current distortion. We see the typical behavior of a 6-pulse drive and the distortion created by this 6-pulse drive. What we can do now is, first of all, we need to identify what do we want to compensate. So we look at the phase voltage, and we can here go to the first half of the spectrum and only look at the harmonics. Here we see that we have high amount of 5th, high amount of 7th, and then high amount of 11th. And if we look at the CT current, we see actually the same information. We have 5th, 7, 11, and then like 13 and 17 is much lower. So that means we can start to compensate, and we want to compensate towards a certain target level. So we are activating now the harmonics compensation. Let's start with everything 0. That's the standard settings from default. And with this setting in, we can now start to put out some current. So we can start with the 5th harmonic. We have at the moment about 45 amps on the 5th harmonic. So if I just put 50% here, we should see this harmonic dropping down. And this is exactly what we are seeing now, and this is what we want to have. So with this information, we know already now that the 5th harmonic is working fine. Now I have to look a little bit on what is my target level, where do I want to come, and what is the size of the active filter that I have available. So my target level right now is to reach a voltage distortion of below 5%. And you see already with this 50% on the 5th harmonic, we're coming rather low down with the THDU. We can increase that a little bit to 60%. And with the 60%, we're coming even closer. We're going to 70%. We're coming even closer. You see, now we're below 5%, and this is already enough for our target level. So we're reaching the target already just by compensating on the 5th harmonic. We can still play around a little bit more on the other harmonics to just compensate a little bit more because we have the capacity available. And with all of these settings, we're now at 4%. 4% is totally enough, nothing more that we need to compensate. Let's assume, however, we have a target level of 5% current distortion. Then you see we need to compensate a little bit more. So we again have to look here at the spectrum, and we see at the spectrum that the 5th is the highest, then the 7th, then the 11, then 13 and 17. So we can do the biggest impact still on the 5th. So if we go here to 90%, we see this dropping further down, and we are at 10% current distortion. Now the 7th has the highest impact. So the 7th, we're going to 80%. This is dropping down. And with this at 80%, we're already at 6% current distortion. Now the highest one is the 11th. So we're looking at the 11th, and let's say we're going just 50%, just halving that down. And if we put that in half, then we are reaching already 5% current distortion that we want to reach, and that's it. We see that there is still some distortion on the CT current, but this is the 5% distortion that we are accepting, and that means we don't need to compensate much more. So we see sometimes that the people are going on a very high compensation levels on all the different harmonics. That is typically not needed. In this example, we just needed to compensate 5th, 7th, 11. In many cases, we're going up to 13 or maybe up to the 19, but that's not that often necessary. Especially if you want to reach a low voltage distortion and you don't care that much about your current distortion. Typically, just working on the 5th and maybe on the 7th is already enough to get very good results. Now to finish the commissioning, we want to make sure that all the settings are correct. So we're going to the configuration and look that here the values are correct. Typically, I want to have an auto start on boot, so let's activate that. An auto restart on alarm, and let's activate that. If we have some control via Modbus TCP or digital input and output, then maybe we don't want to have that information. Otherwise, we want to have that. We have a standby functionality that is available that we can configure as well. And let's do that here right now. So if we activate the standby, we can set up a wake up level and a sleep level. The important thing is the wake up level. So the wake up level is the level where the filter is starting after the sleep mode. And this is in relation to the CT current. So the maximum CT current that we have here is 200 amps. And with this 200 amps, 10% would mean 20 amps on the CT and the filter would start. We see right now we have a rather high current here. If we go with the mouse over the standby information here, we see actually that we have 85%. So if we put the wake up level at maybe 50%, that's more reasonable. And then that means at 100 amps the filter would start. And 85% of this would be the sleep level. That means the filter would go into sleep mode if the current is below 85 amps. We have some wake up and sleep time. So wake up is immediately and going to sleep is after 5 seconds. And let's keep these values. And now what happens if we are reducing the current? Now the current is reduced to 60 amps, so it's below the 85 amps. And then in a few seconds we are going into standby. So now the filter is in standby. If we increase the current again, then we see that the filter will immediately start up as soon as the load is back online. With the configuration done, the only thing that is left for me to do is exporting the settings, so I have them backed up and I know that they are available for later use. I can do software updates if that is necessary. I would typically do that before commissioning. And that is all. So that is all for today. Thank you very much for watching and see you soon.